Today, we will be going over weighted averages. To explain this concept, let's go through a quick analogy. Let's say you have been recently hired at a successful realtor company. As your first task, a client has asked you to help them sell 3 properties: a townhouse in the suburbs for $910,000, an apartment for $2,000, and a mansion for $6 million. Since your pay is related to the prices of the homes you sell, you want to find the average price per property if you were to sell your client's houses for the desired price. What is the average price per property? The correct answer is B. We sum up each value, $910,000 plus $2,000 plus $6 million, and then divide by the number of values. In this case, we get $2,304,000 per property. After successfully making these sales, your client is ecstatic and refers you to a bunch of his friends who are also looking to sell. To your surprise, you now have to sell 20 townhouses, 15 apartments, and 4 mansions. It's a lot of work. To determine if it's worth your time, you again try to calculate the average price per property if you were to sell all of them. Thus, you add $910,000 to itself 20 times, add that number to $2,000 added to itself 15 times, and add that sum to $6 million added to itself 4 times. Finally, you divide that very long expression by the number of properties, 39. We get an average price of $1,082,820.51. After sitting in your office for 30 minutes calculating the average price per property, you start to wonder if there is a more efficient way to calculate your answer. And there is. Adding $910,000 to itself 20 times is the same thing as multiplying $910,000 by 20. Similarly, adding together $15 $2,000 is equivalent to multiplying $2,000 by 15, and adding together $6 million is the same as multiplying $6 million by 4. Thus, we can just add together the sum of $910,000 times 20, $2,000 times 15, and $6 million times 4, and divide by 39. We again get an average price of $1,082,820.51. This way is much faster. You might not know it, but we just calculated a weighted average. Unlike normal averages, weighted averages take into account the varying importance of each value by assigning a weight to each value. The weight represents the portion the value takes up of the whole. What makes a weighted average different from normal averages? The correct answer is C. When working with a weighted average problem, not all the values are of equal importance. Some are more abundant or appear more often than other values, such as how there were more townhouses than apartments. Thus, we will need to multiply each value by its weight. Let's investigate our realtor scenario equation further to clarify what the weight in the weighted average equation is. First, let's write out our previous equation. The average price per property equals 20 times $910,000 plus 15 times $2,000 plus 4 times $6 million, and all of that divided by 39 equals $1,082,820.51. We can distribute the 39 to each term. When we do that, we get 20 over 39 times $910,000 plus 15 over 39 times $2,000 plus 4 over 39 times $6 million equals $1,082,820.51. Or 0.5128 times $910,000 plus 0.3846 times $2,000 plus 0.1026 times $6 million equals again $1,082,820.51. The 20 over 39, or the 0.5128, is the weight of the $910,000. 51.28% of the properties have a value of $910,000. Similarly, the 15 over 39, or the 0.3846, is the weight of the $2,000, and the 4 over 39, or the 0.1026, is the weight of the $6 million. Notice how these weights represent a percentage. The townhouses were the most abundant in this scenario, so they were assigned the greatest weight, and thus the greatest importance in the weighted average. Building off the realtor scenario, we can generate a generalized weighted average formula. Let's say we have 3 values, x1, x2, and x3. These will be the price of the property from our previous example. Each value has a corresponding weight, f1, f2, and f3. Here, f means the frequency or percent of the items with a given value in the dataset, which can also be represented through fractions or decimals. So the weighted average of these 3 values would be f1 times x1 plus f2 times x2 plus f3 times x3. Or in our example from before, 0.5128 times $910,000 plus 0.3846 times $2,000 plus 0.1026 times $6 million. Or 51.28% times $900,000 plus 38.46% times $2,000 plus 10.26% times $6 million. So, how do we know when to use a normal average or a weighted average? If we think back on our job as the realtor with only 3 properties, there was no reason to use the weighted average formula since we only had a few items to average. We would only use a weighted average formula when there are large numbers of items to average and each value in the dataset is not equally as important or some numbers are more abundant than others. Keep in mind that in chemistry, we are dealing with huge numbers of atoms or molecules in a sample. So we'll almost always see the weights as percentages, not amounts of the total, which in the real estate scenario would be 51.28% and not 20 for the townhouses. Let's look at one last example to further clarify. Say we are on a grocery trip and we bought 6 apples for $3 each, 1 box of cookies for $5, and 3 bags of chips for $4 each. How would we write the average price per item? That's right, D. 60% of the items we bought are apples, 6 of the total of 10 items, for example. So when calculating the weighted average, we have to do 0.6 times $3 plus 0.1 times $5 plus 0.3 times $4. That's it for this video. In the next one, we will go more into applications of weighted averages.